GATE 2014 set to electrical question number 43. A star connected 12.5 kilowatt 208 volts line 3 phase 60 Hz squirrel cage induction motor has following equivalent circuit parameters per phase referred to the stator: R1 equal to 0.3 ohm, R2 equal to 0.3 ohm, X1 equal to 0.41 ohm and X2 equal to 0.41 ohm. Now neglecting the shunt branch parameters, the starting current in ampere for this motor when connected to an 80 volt 20 Hz 3 phase AC source is being asked. For NPTEL reference, you can refer to lecture number 36 induction motor of the NPTEL course Basic Electrical Technology by Professor A. Rumanand, Department of EECS, IISc Bangalore. Coming to the useful data, this is the single phase equivalent circuit diagram of a 3 phase induction motor where V phase, this is the phase equivalent circuit, so the voltage impressed on the stator is V phase. For a star connected induction motor, the V phase is V line by root 3. So we have taken V phase, and these R1, X1, R2, X2 are all per phase parameters, and these are the R1, X1 are stator parameters, that is stator resistance and reactance, and R2 dash and X2 dash are secondary, that is the rotor side parameters and referred to stator side, that is why they are dashed. S is the slip. So this is the equivalent circuit, and from here we can find the stator current. The line and phase currents are same for a star connected induction motor, so the stator current I stator can be defined as V phase by root over R1 plus R2 dash by S whole square plus X1 plus 2 dash whole square, because actually R1 is like this and this is JX1. So when you find the net impedance, this is R1 plus R2 dash by S and JX1 plus X2 dash. So the net impedance is like this. Then V phase by net impedance is I phase or I line is same, so I stator is like this. And one thing to note is that the stator or rotor reactances, if we consider it to be XS, that is 2 pi f into Ls, where Ls is the actual inductance value. You see Ls is machine design constant, so Ls is constant, 2 pi is constant, so Xs has a direct relation with frequency. So if you change the frequency, the reactance offered by the inductances will vary. Coming to the solution, these are the values given: R1 equal to 0.3 ohm, R2 equal to 0.3 ohm, X1 equal to 0.41 ohm and X2 dash equal to 0.41 ohm. The frequency, that is, it was designed for 60 Hz frequency and 208 volts line voltage. Start connected 3 phase squirrel cage induction motor. Now it is asked to find the stator current I stator for operating frequency 20 Hz and applied voltage 80 volt in the stator circuit, and the slip at starting. So at starting, when you find slip is ns synchronous speed minus rotor speed divided by synchronous speed. Now the rotor speed at starting must be 0, hence the slip at starting is 1. Slip at starting, so S equal to 1. Now we need to find out I stator. So I stator starting, that is S equal to 1, equal to V phase divided by root over R1 plus R2 dash by S plus X1 plus X2 dash whole square. Now S equal to 1, so we can write it as, and V phase equal to 80 by root 3, because 80 volts line to line voltage was impressed in the asked condition in the question. So 80 by root 3 is the phase voltage, and R1 value is 0.3, R2 value is 0.3 as in the question, and these are 0.41, this is whole square, this is whole square, plus this is 0.41 plus 0.41. But now you see these 0.41 values are for frequency 60 Hz. Now frequency has become 20 Hz, that is the operating frequency. So if operating is f by 3, so x is x old, or x new I can say, is x old by 3, because of the direct relations with the frequency. So what we do, we divide by 3, and then you take the whole square and root over. So this value is coming out to be 70.05 amperes. So the answer is 70.05 ampere in this operating condition.